Welcome to the first of two videos that will show how to graph functions with multiple transformations. This video does assume that you've already watched the videos that show how the values of a, b, c, and d in this form transform f of x. So if we have f of x equals negative 1/2 times the absolute value of the quantity x plus 1 minus 2, we need to be able to recognize that a would be equal to negative 1/2, which tells us two things. Since a is negative, this is a reflection about the x-axis, and that it's been vertically compressed by a factor of 1/2. Next, c is equal to positive 1, and if we see x plus 1, that means this graph would be shifted left 1 unit. And d would be equal to negative 2, which means the graph is also shifted down 2 units. So it's very difficult to graph all of these transformations at one time. So what we're going to do is take this in steps. I've already provided the parent function y equals the absolute value of x. Let's go ahead and identify some key points on this graph, like the origin, maybe the point 4, 4, and maybe negative 4, 4. Next, we'll first graph the reflection and the vertical compression. So we're going to graph y equals negative 1/2 times the absolute value of x. Remember, when a is equal to negative 1/2, we can take these points on the parent function, multiply the y-coordinate by negative 1/2, and leave the x-coordinate the same, and that'll give us points on the transformed graph. So the transformed graph will still have the point 0, 0, but now when we multiply this y-coordinate by negative 1/2, we'll have the point negative 4, negative 2. And we multiply this y-coordinate by negative 1/2, we'll have the point 4, negative 2. So this will be the graph that has been reflected and vertically compressed. Now we're going to take these 3 points and shift them left 1 unit and down 2 units. Let's go ahead and label these. So in order to shift each of these points left 1 unit, we'll subtract 1 from the x-coordinates, and then to shift it down 2 units, we'll subtract 2 from each y-coordinate. So here, if we subtract 1, we'll have negative 5, and then subtract 2, we'll have negative 4. So the point negative 5, negative 4 would be here. Subtract 1 from the x-coordinate, we'd have negative 1. Subtract 2 from the y-coordinate, we'll have negative 1, negative 2. And then lastly, subtract 1 from the x, we'll have 3. Subtract 2 from the y, we'll have negative 4. The point 3, negative 4. And this would be the graph of the original function that was given to us. It's been reflected, it's been vertically compressed, it's been shifted left 1 unit and also down 2 units. Let's go ahead and try another one. This one's a little bit trickier. We have to recognize that it's not in the exact form that we want it to be, meaning if we want b times the quantity x plus c, we're going to have to factor out the 2 from 2x minus 4. So let's rewrite this as f of x equals the square root of 2 times the quantity x minus 2 plus 1. Let's go ahead and identify the values of a, b, c, and d. In this case, a would be 1, b is equal to 2, which means this graph is horizontally compressed. Next, c is equal to negative 2, which means the graph will be shifted right 2 units. And d is equal to 1, which means we'll shift the graph up 1 unit. Next thing, we have to recognize that our parent function is going to be y equals the square root of x. I've already completed a t-table for this function to save us some time. Remember, when we have a horizontal or vertical compression from a value of b, we leave the y-coordinates the same, but multiply the x-coordinate by 1 over b, or just divide the x-coordinates by b. So let's go ahead and take these x-coordinates, divide by b, and leave the y-coordinates the same for this horizontal compression. So we'll still have the origin. Next, let's skip this one because it'd be a fraction. If we divide 4 by 2, we'd have 2 for the x-coordinate and 2 for the y-coordinate. So we have the point 2, 2. Let's go ahead and skip 9 and go to 16. If we divide 16 by 2, that'd be 8. The y-coordinate stays 4. These 3 points should be enough to make a nice graph that has been horizontally compressed. Now we're going to go ahead and take these points and shift them right 2 units and up 1. Let's go ahead and label them. We have the origin, we have the point 2, 2, and we have the point 8, 4. So we'll add 2 to each x-coordinate and add 1 to each y-coordinate. So the origin will become 2, 1. Add 2 to the x-coordinate, that'd be 4. Add 1 to the y-coordinate, that'd be 3. So the point 4, 3. If we add 2 to the 8, we'd have 10, comma. Add 1 to the 4, we'd have 5. 10, 5. And then we'll make a nice graph through these 3 points. It looks something like that. This graph has been horizontally compressed, shifted right 2 units, and also down 1 unit. So the idea here is that if you know how to graph a parent function, you should be able to graph a transformed function fairly quickly and easily without the use of a graphing calculator. I hope you found this video helpful. We will take a look at 2 more examples in part 2 of this video.